So we'll go back to my page 1. So inside of my page 1, I put my koala picture. And the idea behind the next demonstration is to try to perform a rotation on the image, but the rotation will be done through the detection of an acceleration on the phone itself. So the idea on my example page, we'll try to minimize a little bit so that you will see a lot of code. So I have my image. And at the end of my image, I will just close my XML tag just later on. It's to work on a particular projection. And so inside of my image tag, I will be able to manipulate the different projections that are proposed on my image. And inside of the projection enumeration, I will work onto the plane projection. And instead of my code, each time to define my image, the projections, and then instead of the projection, the plane projection, and then working onto the rotation, I will make in this way a kind of shortcut inside of my example, so that inside of my code, when I need to modify the rotation of my image, I can directly do it through the variable proj. Okay, and so this is the part of my my graphical side. So just defining a kind of shortcut to the projections of my image. So next operation that I need to do is to figure it out inside of my project what kind of accelerations my device will receive. And so to be able to do that, the next operation that I will do is inside of the references, I will need to add a reference to a specific library that handles the accelerometer object. And so the first library that is defined inside of the list, which is device.sensors, I will include it inside of my project. And then I will switch to my background code instead of my page 1. So the idea is to, depending the acceleration that will be detected on my phone, to just make the rotation inside of my image. So first operation will be to create an instance of my accelerometer. Object. And so, of course, I need to add my using Microsoft.device.sensors. And so I have my accelerometer object. I will call it ACC. I will directly instantiate it inside of my code, just putting the font a little bit huger. So we'll create a new instance of my accelerometer. And now inside of the constructor of my page, I will associate to my accelerometer object a specific function, which is reading change. And behind the reading change event, it will automatically generate my event. And inside of my event, I will implement the mapping in between the acceleration that I detect and the rotation of my image. So next operation that has to do inside of my initialization will be the startup of the acquisition of the accelerations. And then last thing will be to do my mapping in between I receive an acceleration and what will I do on my image. So if I just do my projection in this way, so I have my projection, and inside of the properties of my collection, I will have the rotation. So we'll do a rotation on X, and we'll rotate depending the acceleration detected on Z. So you have to figure out if I take my phone, I don't know where is my phone, but suppose that my mouse is my phone. The image will be displayed on top of my phone. And we have the X, Y, and Z axis in this way. So this means that if I need to modify the rotation in this way of my image, I have to work on the rotation on this axis. Okay. Now, the accelerometer will give me accelerations. But the acceleration that I need to retrieve on this axis will be a rotation that comes from here. So the acceleration is detected on this axis, and the image and the rotation of my image will be done onto another axis. So this means that for rotating my image, and the x-axis of my image will correspond to an acceleration coming from my vector on the axis z. I have also to convert it to degrees, and I will do it onto the z-axis. That will allow me to handle the rotation of my image in this way. And this will be depending, if I take my rotation, if this is my image, if I rotate it in this way, this means that I have some force which is coming, acceleration coming from this axis, which is the z-axis of the accelerometer. Okay. So, define my x, and I will multiply it by minus 90, which is my mathematical formula to map my accelerations to my image. So if I do that in this way, I may have some little problem in the way that anything that will modify a graphical feature of my application must be done in all the cases in the main thread, the thread that handles the user interface. So to be able to guarantee, even if my sensor will send me those informations through a background thread, that the mapping and the projection that I'm performing will be done instead of the main thread, I will use the dispatcher, and inside of the dispatcher I will have begin invoke that receives a specific function, and this function will be executed in all the cases inside of the main thread, the thread that handles the graphical interface. So instead of making a function, declaring this function, moving my code, etc., what I will do is just inline the code that has to be executed inside of the parameters of my my begin invoke function by specifying in this way that the code that is executed inside of this scope must be done inside of the context of the main thread. Okay. So if we are already inside of the main thread, this code will be synchronous. If we are not in the context of our main thread, this part will be delegated and will be done in the main thread for that. So if I run my application and going to my page 2 that handles my Koala, I have my Koala there, and if I want to test out my my implementation, if you just go to the menu of your emulator and go to the right side, you have 2 arrows which will open a specific toolbar, and inside of this toolbar you have the emulator for the accelerometer, which means that each time you will hit the red button and you will exert some accelerations onto your phone, you will have your image that will rotate in the same way as the one that you perform onto the phone inside of the toolbox. So this demonstration will run well fine inside of the emulator environment because my emulated phone is fixed. If I do that on top of a real phone, if I perform an acceleration on my phone, I will have my image that will double the rotation because it will have the rotation, but because my image will rotate more, I will not see anything. So it's a demonstration which is very fine inside of the emulator, and where I will be able to manipulate my accelerator. Okay, I can of course check my Koala. And so this is for the accelerometer. So the idea is to show you that inside of the environment, just figuring out and detecting the acceleration of my phone is something which is really easy to detect and to handle inside of my application. Of course, what you do with those accelerations, it's up to you to define what kind of application you want to do. Okay. Of course, there are not a lot of Silverlight applications that are using the accelerator, but the next demonstration will focus one of the functionalities which is maybe more important, which is the location services. So having the GPS module typically. So the idea of the next demonstration will be just focusing on the same screen as the one with my Koala. So we'll stop my execution. So I will put my Koala at some part of the screen here. And the next operation will be to check out how to include positioning inside of my application. So for that purpose, I will take a map object. Okay. So by default, the map object will display the zoom level at, with all the different continents. This means that if I want, behind my demonstration, allow me to see where I'm currently located at the street level, so that when I'm walking inside of the street, I see inside of my phone just all the cards, just panning and moving, and always having the location that I'm detected by the GPS, which is the center of my map. So the first operation that I will need to do is inside of my graphical part to just modify the zoom level of my map. So I will, instead of my map object, just walk on to the zoom level. And if you specify 16 or 17, you will have a zoom level which allow you to see the streets. Of course, by default, the map control will position himself in the middle of the sea. So this means that we are zooming inside of the sea, so everything is blue, which is normal. So this is for my graphical part again. So next operation will be inside of my code to initialize the GPS. And I will use my geo-coordinate watcher object. So it's not called GPS because the way the system will be able to find its location can be done by the GPS module, but also by the cellular network or by the IP address. So of course, receiving a position by the GPS will give us a very precise location. If we deduce location through the IP address or by the cellular network, it will be lesser accurate. But depending the need of your application to have a location, a good precision or a low precision can be fine. Just taking an example, so when you publish your application to the marketplace, you will be able to define if you want to sell your application and giving a price, or if you want to publish your application for free. So most of the applications now are for free, but the developers who publish those applications will earn some money through the advertising SDK. So it's a control that's put onto the screen that will display some advertising. So instead of the advertising SDK, you will be able to provide the location where you are. And the main idea is to provide you with the right kind of advertising. So if you are in Antwerp, you don't care about I don't know, the prices of some caps in New York. But you prefer, or as a publishing advertising company, I prefer to be able to send you some advertising related to the region where you are. And so through the advertising SDK, we'll be able to give the location. But we don't care having the right location at the street level, but having a location that just defines that we are somewhere in Antwerp. Even we are somewhere in Belgium is fine enough to focus the advertising for my device. Of course, if you are making an application that really tracks some people or some cars or whatever regarding to the device, then you have to need a precise location. And this is what we will do here. I will create my geo variable, creating a new instance of my geolocation service. If we check out the first parameter that we can give inside of the constructor, you can define what kind of accuracy that you need inside of your application. So you can decide if you want a precise one or a low resolution one. So for advertising, a low resolution will be fine enough. And moreover, deducing the location through IP address or by using the cellular network will also cost lesser regarding to the battery. Okay, because your Wi-Fi connection is most of the time always on. Your cellular network, because it's a phone, you are connected to the cellular network. And so retrieving this information will use lesser battery than just starting up the GPS module, time to synchronize with the good satellites, and then calculating the position. It will cost more battery than just using the cellular network. So once I have make my object, I will be able to initialize it. So in the same way as my accelerometer, I will handle some events. So the first one will be position changed. So as the event give it as name, each time I will have a new position that has been received by my implementation and by the GPS module. There will be a call to this event with the new location. So I will do my handling later. Next event that I will associate to my object will be the status change. So this is very important when you deal with making an application that will use the GPS. So the accelerometer, when you instantiate it and you start the acquisition, you are sure that the functionality of your accelerometer will be always there onto the phone, because the accelerometer is not relying on whatever external feature. In the case of the GPS, it's radio. It's depending on the reception of the different signals of different satellites. And so if you are inside of a building or inside of underground parking, you will not receive a valid GPS position. And so you have always to figure it out when you are making your application about what's happening when I don't receive a valid location from my GPS module. So what will I display to the end user? What will be the comportment of my application, which is relying on a location when there is no location that can be deduced? And so inside of the status change, you will be able, depending the status, to make some other cases and implement some other cases regarding to the normal behavior in which you receive your location. And by the examples is you get some valid location, or the GPS is started up, but you cannot get any valid location, don't have enough satellites in SIG to be able to calculate the valid position. Or another case is the end user has disabled the GPS module inside of the settings of the phone. So maybe the handling of the last one will be to pop up a message box to the end user, asking him, if you want to use the full features of the application, you should enable the GPS through the settings. Okay. So really important to handle the status inside of your application. And next thing that I'm always modifying will be the movement threshold. So the movement threshold has by default the value of 0, and the movement threshold defines when the next position has to be provided to the application level. So what's happening is that when I'm walking on the street, every second I will receive a valid location of my GPS module. Of course, if I have enough satellites in SIG and so on. But this means that once I'm not walking anymore and staying just at the same position, every second I will receive inside of my application the same value. So this means that if I don't want to handle receiving the same value, putting this value to the map, having the map that will update himself, and just at all the end detecting that nothing changed. To avoid all those different treatments, I need to handle inside of my implementation all the same values that are coming in sequence. And so to avoid having to implement that inside of my code, I will just ask the system, okay, give me the next position only if this next position has a difference of more than 1 meter regarding to the previous one. If I specify my application 5 or whatever, this means that I will receive the next position only if there is a difference of 5 meters regarding to the previous one. So this will minimize the amount of treatment that you will do inside of your application. By minimizing the amount of treatments you're doing inside of your application, this means that it will minimize the battery impact, and so be more mobile friendly regarding to your phone. So in my case, I want to have a precision of 1 meter. So if I'm not moving, I'm just standing on the right light or whatever, I don't want to handle all the same positions, so I don't put 0, but I put at least 1. If you are making, for example, an application that will track down a way that you are doing, but and you save those different positions inside of a file, maybe having a granularity of 1 meter is too huge, just to keep track of what's happening. So maybe you will define, okay, every 100 meters difference, I will just take the position. So this will minimize the amount of CPU time and also minimize the amount of storage space used by the tracking system. And also if you need to upload this tracking file to a server, this will also minimize the amount of bytes that has to be transferred to the server. So from end to end, you will be able to optimize by reducing the amount of resources that are needed by the application on the phone, and so reducing the amount of battery that will be necessary to be able to complete the full end of your application. So once I have initialized everything, I will be able to start the acquisition of the current position. So I will not perform any implementation inside of the status change function, but I will do it inside of the position changed. So the idea is the same as the accelerometer. I will just cut and paste this part of the code, which is my sensor can call me through a background thread, which means that because I'm modifying something in foreground, I need to be sure that modifying my map is done inside of the foreground thread. And so I will call my dispatcher begin invoke. And regarding the update of my map, if I just enter the center property, taking the parameter that I receive from the GPS part, instead of position, I have a property which is location, and I can just assign the current location that was detected as the center of my map. And so each time I receive a new coordinate, giving it to the center of my map, the map will automatically update itself to be able to center it onto the map. So if I run my application, I hope I didn't forget anything. Okay. So taking back my emulator, going to the screen where everything is on. So the first thing that will be done is, depending the current location of my emulator, so if I take back my tool window, so the default position that is displayed inside of the tool window is a building that contains the developers of the Windows Phone. So it's a particular building at the Microsoft campus. So here we are, of course, not in the same country, neither the same state. So we'll just switch to something which is more near here. And so we should be somewhere here. I will be able to zoom. Let's say that we are here. Okay, whatever. So we set my points. So the idea is each time I will click onto a particular position inside of the map, automatically the system will update the GPS which is inside of the phone emulator, so that it will send to the applications that just ask it the position, the current position. And you will be able, inside of the emulator, to just create a kind of walkthrough by specifying, okay, I'm here, and if you want to accelerate, you will just increase the distance between the points. Suppose that you are waiting onto a red light, which is here. So I'm waiting, okay, I'm starting up, taking the road at here. I think if I do that for real, I will have a small problem due to the arrows. But okay, it's just an emulation, so should be no problem regarding to the road. And so here, once I can be able, for example, to save all my different points, to be able to reload them later on. And then if I switch from live to non-live, I can, for example, replay all my different points every 2 seconds. And so automatically, I will be able, inside of my application, to test out my application with the context of a GPS when I'm moving and making some kind of road. Of course, because I serialize everything regarding to the user interface, I can continue to switch and to check my my small koala in the same time that I receive my positions inside of the system. Okay, so this is for the demonstration about how to include inside of your code the accelerometer, the GPS. So just remember, once you make your application using the GPS, don't think that you are sure to receive a valid position inside of your application. Always think your application on what will happen when I will not be able to retrieve a valid position. What will I display to the end user? What are the alternate features that I will be able to provide? And same remark for the Bing Map card. So each time I will position myself, so each time the system will display the cards, so each card will be online downloaded through the Bing Map server. So this means that if I don't have any internet connection, any data connection available at that time, I will not see anything inside of my map control, because the map control is something that is always linked to some services that are displayed and available inside of the Bing Map server. So for the same question, you must ask yourself, do I have a valid position inside of my application, because my application relays on having a location? You can ask yourself the same question regarding to the data connection. Normally, my application needs a data connection to be able to work well. What's happening if my user is using my application and I don't have any 3G connection, no edge connection, no Wi-Fi connection? What's happening at that moment? What can I be able to propose to my end user to be able to do that? So if we are talking about data, of course, my online application or my application can check out online if there is a network. We'll be able to, for example, synchronize some small amount of data. So downloading when it is used the data and storing this data locally inside of a file or inside of a SQL CE database. And now to be able to your application to be used even if there is no network connection, one of the common ways to do is to perform some small synchronization in background. And so this will be done through the background agents. And the next demonstration, we will just figure out how to implement a background agent and see how we will be able to do that. So let's say that, let's imagine that I have some data available onto the network somewhere, and I want to regularly, every period of 30 minutes, because it's the smallest granularity that I have, being able to just query my server, checking out if there is some new data that has to be retrieved, and eventually notify my user that some new data is available and that he has to go to my application to check out this particular data. So my background agent is something which is not inside of my application. So this means that I need, instead of my solution, we'll just stop my solution to run. Instead of my solution, I will create another extra project. And this time I will choose the last template, which is the Windows Phone scheduled task. Of course, I will be able to give another name. And once I create this new project, I will have my scheduled task agent that will be generated, and I have my onInvoke function. So this means that my scheduled task agent is an external library, will be a DLL inside of the project that I will have to deploy. And every 30 minutes, the operating system, if there is enough CPU time, if the battery level is okay, so depending all kind of questions regard of the stability of the platform and the user experience, if everything is okay, your background agent will be scheduled. So also, don't think about, I am sure that every 30 minutes my background agent will be started up. This is the best case. Sometimes the operating system can decide to postpone the execution or even stop the execution of your background agent. Okay. So in the case of my background agent, I have the onInvoke function, and it will be at this place that I will implement the logic of my background agent, the logic that will be on what will be executed every 30 minutes. So in the case here, I will not, of course, implement all the logic to check out online to my web server, prior to checking online to my web server, checking out if I have a data connection, if I have some new information, storing locally my information local to a file or a database, and then notifying my user that some new data has to be handled. I will directly go to the notification of my user. And what I will do is call a shell toast. So the shell toast is also something new inside of the Mango release. This allows me to just make a kind of pop-up to the main screen of my Windows Phone, or typically when my phone is in idle state, or when you are inside of the main menu of my phone. This will specify a small message to the user, so-called ST. I will create directly a new instance of my shell toast. Up to you to define all the properties that are going fine. So we'll just add the title. I will add the content. So it will display hello world. And I will be able to just show the toast to my end user. What I would like also to do inside of my shell toast is that if the user is clicking onto the toast, if the user is clicking onto this kind of message that will appear, I would like to automatically, my application and my user will be sent to my application. Okay. So this means that I will be able, instead of my shell toast, to add some extra parameter, which is a navigation URI. So in this case, I will create a new URI, defining that once the user click onto the toast, click onto this kind of small, let's say modeless dialog box, it will go to the main page of my application. So, in the case he's hitting that, he will go to the main page. Okay. Just normally should be no problem with lower cases and upper cases, but I prefer each time to keep them. And so in this case, once my toast will be displayed, it will automatically perform a navigation to my main application, to my main page of my application when the user click on it. So I will already put my breakpoint for later on. So I made the implementation of my shell toast. What you will be able also to do, and instead of a real implementation, you can also implement the on a board function. So what's happening is that the operating system can at any moment decide not to schedule your background agent. But also the operating system can decide at any moment to stop the execution of the current background that is currently executing. So taking an example, instead of your idle background agent, you will run for a couple of minutes, and one of the rules is there may be no communication that is going on, because your device has to be in sleep mode. So what's happening is that maybe the background agent will be started up because it is connected to the power plug. Battery is more than 90%. Wi-Fi connection is available, so it starts the background agent. And your idle background agent must be running maybe for 5 minutes, but after 2 minutes you receive a phone call. So you take your phone and you begin to discuss with the person that is just calling you. But this means that one of the rules that defines that there may be no phone call is not more there. And so the operating system will just decide to stop the execution of your background thread. It will call the on a board function. And in this way, you will be able to stop gracefully your background agent. If you don't obey or don't stop the execution of your background agent fastly enough, the operating system will just kill your background agent. Okay. So in my case, I did the implementation of my background agent. So the next operation to perform will be to include my background agent inside of my deployment package. So if we go back to the XAP file that we did previously, we have our application, but we don't have the DLL that implements the background agent. So to perform this operation, I will add a reference, but this time I will not add a reference to one of the libraries of Microsoft, but I will add a reference to one of my own libraries and the one that implements the scheduled background agent. So by doing that, just by performing an add to the reference, there is some code behind that has been executed. And if we check inside of the application manifest, you will see that there is some additional information that has been added inside of the manifest that will make the link between, okay, there is now a background agent that is available inside of the project, and this background agent is located inside of this file. You will see that later on when we will schedule our background agent, we will not specify any information about where is located my background agent. But by adding my background agent implementation through the references, it will perform a specific link inside of the application manifest. And when we start up our background agent, the system will automatically retrieve this information from this manifest file. So it will be easier for us to make the implementation. So next operation that will be done is I need to start up my background agent. I need to schedule my background agent. So what I will do here is just inside of the main function, so the application launching, I will create my and schedule my background agent at this part. So to be able to do that, I will create a periodic task object. So my periodic task object will implement my the object managed by the operating system that represents my background agent. We'll call it a periodic task. And by default, the first time I need to execute this code, I will have to create a new periodic task. So what's happening is that later on, inside of my code, if I want to stop the execution of my background agent, or replace it, or do whatever kind of operation on it, I need to be able to reference my periodic task in a unique way. And the string that you give as parameter will be the unique identifier for this particular task that you set up. So you will be able also to give some description, for example, because the user will have the ability through the settings to stop explicitly the background agent. And once I have filled in all the different properties about when should my background agent begins to be scheduled, when I want it to be ended, and those kind of things, I will go to the scheduling action service. So the scheduling action service is the central point of the operating system that will schedule all your alarms, reminders, background agents, and those kind of things. And so this is a collection of things that has to be executed by the operating system. So I will add my periodic task inside of the collection. And so in this way, my periodic task will be executed and scheduled every 30 minutes for 15 seconds. Okay. Now, of course, this implementation will be fine the first time I will execute my code. Once I execute it for the second time, I will get an exception on the add function. So I need to figure out the second time I will execute my code if my background agent is already scheduled or not. And so I will do that in this way. I have a find function. I will check out if there is some background agent that has the same ID as the one that I create, because my IDs are just local regarding my application. So we have other applications having the same ID, don't care, because each application is related regarding to the others. Because the scheduled action service just gives us a way to schedule different types of things. So if we check out the type of object that will be returned, it will be a scheduled action. Scheduled action is a base class where you have a lot of other classes that inherit, like periodic task, resource intensive task, alarm, reminder. All those different things will inherit from scheduled action. And so here I have to just map the returned object to a periodic task to be sure that the compiler doesn't say anything. And then next operation will be to test out if my periodic task is different to null, to be able to perform some action. So by default, common implementations will do that. So the scheduling action service, remove, and your specific background agent. And then once it has been removed, it will create it again. So we can say at the first view of this code that it's a little bit stupid, but there is a good reason to perform this kind of code. The main reason is that your background agent will be scheduled only up to 14 days. So this means that after 14 days, the operating system will not schedule anymore your background agent. And the only way to just have an extra 14 days will be to remove it from the list and to add it again. Each time you perform an add operation, you will be up and running for 14 days. Okay. So this means that in this way, each time that the user will start up the application, we have 14 days in which my background agent will be executed. So we'll put my breakpoint here. So now if I compile my application, just going back to my project, if I check out my exap file this time, we'll remove the old one. So renaming my exap in zip, then going down, I see that this time my background agent will be included inside of the deployment package. And because it is located inside of the same deployment package, it will be part of my application, which means that any resource that my application will be able to access, my background agent will be able to access the same resources. So for example, if my application will write some files inside of the isolated storage, so the file system which is associated with this application, my background agent will have access to the same files, to the same isolated storage. This means also, and we'll see that inside of the execution, that once I execute my background agent, and that my background agent will be scheduled, it can be that my background agent be scheduled in background when my foreground application is the application which is related to my background agent. If both access to the file system, to the same file, you have to guarantee that if both are reading and writing, that the integrity of your files is still saved. So it will be up to you to set up a mutex, name it mutex, so that you will control the mutual exclusion of the file access in between your background agent and the foreground application. So I will run my object here. So the ID, of course, it will deploy the new package with the new background agent inside. The first execution, of course, I don't have any background agent that is running with the IDC. I will create one and I will schedule the new one. So if I just do that, nothing will appear. For now on, I will have to wait 30 minutes before my background agent will be set up. So of course, waiting 30 minutes will be a little bit boring. So one of the functions that has been added inside of the scheduled action service is launch for test. So the launch for test function will allow me to launch the specific thing which is behind C, but not after 30 minutes in the case of a periodic task. But I will be able to just define that I will execute it after 15 seconds. So in this way, I will be able to test out and to debug my background agent without having to wait 30 minutes each time that my background agent will be started up. So watch out, this function may be used only in the context of debugging your application. So if this function is part of the retail code that is submitted for certification to Microsoft, your application will be refused. So the best thing to do in a real application will be to encapsulate that in a preprocessor condition, like dash if def debug, and having this line, and then dash and if, so that this line of code will be present only inside of the debug version and not in the release version. So we'll run it again and start it up again. So I have my periodic task, and this time I will have 15 seconds. And if I just have both of them in parallel, my background agent will start up a shell toast, and the shell toast will appear only when my application and when my phone is inside of its main menu. So within those 15 seconds, I will just hit the start button of my phone emulator. So this time, of course, my scheduled action already exists, so I will remove it, and then I will start up it again, and now I will have 15 seconds to just click inside of my main menu. And now, what's happening is that after 15 seconds, the system will detect that it has to schedule a background agent. Once it detects that, the operating system will load this particular background agent. We see that I have my foreground application that still exists in memory. I have my background agent, which is inside of another process. So both continue to exist together. Okay. So if you have some file access, you have to keep that in mind, that you have to use a mutex to mutually exclude the access of your files through the different applications. So in my case, it's very easy. I don't do any networking stuff. I will just notify the user that something has to be done inside of the main application. So I will hit my F5. And so I have my shell toast that appears. And if my user click onto the shell toast, because I have specified a navigation URI, I will go automatically inside of my application. Because any startup of a new instance of my application will close the previously running instance. Because it's a new instance, I go inside of my application launching. Inside of my application launching, automatically I will reschedule after 14 seconds the execution of my background agent. And so in this case, I will not go out of my application. I will be able to use my application. I will see inside of my debug environment that I will be scheduled. So if I take back my locations, taking a particular way within here, I will execute that. If I find back my tool window, and so I have my toast, I have my execution in background, and if I go back to my tool window, I will be able to start it up every 2 seconds. And so everything will be running at the same time. And so my background agent may execute at the same time my main application will be able to run and follow my different other operations. So this is for the background agent. So this means that within my application, I may have my main application that is running. I may have a background agent that just asks the end user to perform some actions. No, last demonstration is just to figure it out some of the things here, which is instead of having a notification that asks the user to go to a specific application, what I will be able to do is directly go to my page 1. Okay. And if I'm performing this kind of operation, I will have some strange, not really strange behavior, but a behavior that should not appear inside of my application. So just waiting that my background agent will be started up. Okay, I run it, and I click onto my toast. So this means that this time I have my application that's started up, and I go to my page 1. But in the sequence and in the way the user commonly use my application, page 1 is not my main page of my application. Okay. So this means that, we'll stop this here. So this means that I am directly inside of a page, a sub-page of my application. And if I use the back key, what the user expects through this back key is to go one level higher inside of the sequence of the different screens of my application. Because here, I just, when I hit the back key, I go back to the previous page. The previous page was the main page. This is because I had a direct link, a direct shortcut within my application. So we will see inside of the next implementation how to be able to just map ourselves again to the main page and what are the different implementations that can be done through that. So instead of my implementation, so don't need any more my background agent, we'll just leave it here. And so here we will walk onto our different pages. So inside of my page 1, if I view the content of my page 1, what I would like to do is, if I'm coming from a direct link to my page 1, is to give the ability to the end user to go back to the main page of my application. So that my idea would be to set and reset the navigation within my application so that it continues to be normal, and setting my main page as the first page of my application. Okay. And so what I will do here is add a particular button, and inside of this button I will go inside of my XAML, and inside of the content we'll say go to main page. Okay. So this means that when I'm coming from my shortcut, could be a tile shortcut or could be the shell toast, I would like that this button will be displayed to the end user so that my end user can go back to the main page of my application. And so starting the normal experience of using my application. So of course, I would like to display the code that I will put behind my button will be navigate. To the main page. So we'll create the navigation to my main page. Okay. But if I do that inside of a regular application, so if I start my application right now, so this means that taking my emulator, I go to my second page, but this means that from my second page, I can perform a forward navigation to my main page. And so I will be able to loop, and when my user will hit the back key, when being inside of the main screen, if I use the back key, it will not go out of the application like he expects. So this means that my button should be displayed only when I'm coming from a direct link, when I'm coming from my background agent that just fired up the shell toast. And so if I take my implementation of my page 1, what I will do is display this message box only if I'm coming from a direct link. And the way I will be able to figure it out if I'm coming from a direct link will be to test out if I don't have any back entries inside of my navigation stack. So we'll override a function, which will be on navigate to. And inside of the application, inside of the function of on navigate to, I will test out my button. And within my button, I will modify the visibility feature depending the navigation stack. So if I take the navigation stack, I have a particular property which is can go back. So this means that if I'm coming from a direct link, so coming from my shell toast, I go directly inside of my page 1, and can go back will be set to false, because I cannot go to a previous page within my application, because my page 1 was the first page. So if I take the can go back, so if can go back is set to true, this means that I'm coming from a direct link, and so it will be visible. Else, if can go back is equals to false, if can go back is set to true, this means that I can go back, so there is a previous image, so it will be collapsed. So just figuring out. So can go back defines if there is a page where I can go back inside of my application. If it is true, this means that there is a previous page. So this is the main page. So if my main page is there because I can go back to my main page, I don't have to display my button, so it has to be collapsed. Else, if can go back is equal to false, this means that I don't have a previous page. If I don't have a previous page, this means that I'm coming from a direct link, and then I need to display my button. Okay. So this will resolve if I need to display this particular button or not, to avoid making any loop inside of the treatment of my application. Now, this is for the page 1. Now, if I go to my main page, I will have maybe a problem, because if I use my direct link, I go to my page 1. From my page 1, I will be able to go to my main page. But this means that the user, when he will hit the back key onto my main page, will not go out of the application. It will return to the previous page, which was page 1. And so, instead of my main page, I need to make some implementation to guarantee that once I'm coming from my page 1 because I was coming from my direct link, I just reset the backstack. So we'll check out, instead of the navigation service, so again, can I go back? And if I can go back from my main page, this means that there is a previous page. The only way to have a previous page regarding to the main page is that I'm coming from a direct link. And in this case, I will just call the navigation service to be able to reset, to remove the back entries. So to reset my navigation stack within my application. And so having the main page, which is the first page inside of the navigation stack. And so, in whatever kind of situation, if I just run my application and try to figure out the case where I'm coming from my direct link, just waiting my 15 seconds. Okay. So I have my shell toast, we'll remove the breakpoint, execute it, go back inside of my emulator, I will go to my page 1. So because I'm coming from a direct link, my button will be displayed. So if I go to my main page, this time if I hit my button, I go coming from my main page, I don't see my button. If I go back, I'm coming to my main page. Because when I came initially from my page 1 to my main page, I reset the back entry so that from my main page, if I hit the back key, I go out of my application and I don't come back to my page 1. If I hit my back key, I go out of my application and I have the normal navigation that is expected within my application. And so inside of the Mango release, we see that through the demonstration here to have a shell toast that allow you to go directly inside of a specific part of your application so that the end user does not have to start from the main page. And if the page that contains the information that it needs to handle is a level 10 page, you don't have to just navigate from page 1 to page level 2, page level 3, etc., etc. It will be able to directly jump where the information is available and that he has to handle. Okay. But through the new navigation services that are provided by Mango, even if you have a jump to an internal page of your application, you will be able to switch back to the main page, and so providing to the end user a normal navigation inside of the application, like if he was just coming through the normal shortcut of this application. Okay, so didn't display yet my different icons. So this is my application icon. If I just hit the pin to start, you can see that the background.png is the image that is used in background here for that. So this ends the set of demonstrations for the phone. Just figuring out where is located my phone. Just taking another one. To end this discussion, just want to conclude to one particular point. So what's happening is that, for my opinion, onto a phone, whatever kind of phone, can be a Microsoft one, can be another one, once you decide to make an application for a mobile phone, you have to ask you the one first question, which is, in which context will your phone be used? Okay. And I will define my own vocabulary for that. I will say that there are two kinds of phone applications that you will be able to develop. The first one are rich applications, and the other one are real mobile applications. Okay. And so the main difference between both will be, inside of a mobile application, your application has to be usable when you take your phone in this way. So if you can use your phone only with one finger, if you will be able to read all the information that are displayed onto the screen at this distance, which is 1 meter, then you have a good Windows mobile application, a good mobile application, sorry. If for any reason there are some information that could not be read because you have to do that and get your phone back at about 30 centimeters, 50 centimeters of your face, that for any reasons you need your 2 fingers to be able to use the phone, then you have a graphical interface that is more convenient for rich applications. And the main difference is the context in which you will use those applications. So when you are walking in the street, when you are inside of your car, when you are in whatever reason where you cannot pay a full attention on the screen because you have to pay attention where you are walking, where you are driving, then you need to create your screens so that they can be easily used with one hand, and also that the user, with just by checking out what's happening on the screen, will be able to find out the information and also to read the information that is displayed onto the phone. At the other end, rich applications. So a typical example of a rich application is a game. So when you are handling or making or using a game, in most of the cases you will be in this position. You need your 2 eyes focused onto the screen. You need maybe your 2 fingers, your 2 hands, and for that it will be a rich environment where you will be able to set up a lot of animations, a lot of colors, because you will be able to pay full attention onto the screen of your phone, and you can use your application. So the first question that you have to ask yourself is, in which context will my application be used? If my application needs to be used when I'm walking onto the street, you will need to create and design your screens, your screen sequence, so that you minimize the amount of information that will be displayed onto the screen, that you use large fonts, and so basically use all the Metro design guides. At the other end, if you are making an application where you know that this application will be used when you are sitting down, and you can pay a full attention on the screen, that you have your 2 hands free, then you may do what you want within the graphical interface, and you will have a rich application. But this kind of application will not be easy to use when you are walking on the street where you have only one hand. So it's really the first thing that you have to question yourself is, I have a good idea, in which context will my application be used? And depending this context, you will design your screens in one way or another one. Also, the second thing that you have to keep in mind is don't assume that the resources that you will use are present. For example, you need to perform some web service calls. Maybe you don't have a network connection. Your application needs the location. Maybe at that time you will not have the location service that will be available. And try to figure out, inside of the implementation, what kind of alternative you want to provide to the end user. And also be sure to test out those cases when you don't have a valid position, when you don't have a network. So test out on a real phone the behavior of your application when you disable the GPS, or when you just disable all kind of network data. What will happen with the application? Will it continue to run? Will it crash? In most of the cases, if you didn't figure out that at the analysis part, your application will crash, because you will try to make a connection, wait for something, update something that is not present on that. So those are the most important parts when making a mobile application, and in some way, whatever kind of operating system, from whatever kind of vendor. Just think your application, in which context it will be used. Don't assume that the resources are present, and put yourself as the future user of your application and figure out what kind of feature do you want to see if you don't have the location, no data or not.